All right, we're going to get started on the second of 3 video lectures that cover Chapter 5 of Baronett's Logic, 3rd edition. The focus today is on sections D, E, F, and G. That is, we're going to work on the assumption that you're comfortable with the following concepts: categorical proposition, universal affirmative, universal negative, particular affirmative, particular negative, the quantity and quality of a claim, whether or not a subject class is distributed, whether or not a predicate class is distributed, and whether or not we assume a member of the subject class in a universal claim exists. What you're going to want to think about is, of course, bringing in what you already know about the categorical proposition, and think in terms of ways in which we can consider the logic of a proposition. By that I mean, certainly on the modern interpretation of the universal, that existential import is not assumed, while existential import is assumed on the traditional or Aristotelian interpretation, but also in terms of whether or not you are more comfortable conceptualizing the logic of a proposition, or like the help of the visual or the visualization of the logic of a categorical proposition, that is its logical structure, by way of a Venn diagram. That said, what we want to do is take all of those elements and employ them as we learn what inferences we can make either from one type of proposition to another, so let's say an A proposition to an I proposition, as well as what happens when we manipulate the proposition itself. So for example, think about what we get when we swap the subject and predicate places of a particular claim. Right? So these are the sorts of things we're going to be doing. The big picture in terms of D through G is the two interpretations of the universal proposition, namely the modern and the traditional. Okay, so the modern square of opposition is the modern interpretation of the universal in terms of how we can or not make an inference from a universal affirmative to a universal negative and vice versa, universal affirmative to a particular negative and vice versa, and so forth. You'll see in a little bit why it's called a square of opposition. But for the moment, let's just do a little bit of background work. So when we're thinking about the sentence, all unicorns are mammals, we are thinking in terms of not assuming that the not assuming that the subject class has any existent members. It might help you to think of the universal on the universal affirmative on the modern interpretation as saying if something is a unicorn, then it is a mammal. We're not saying that any unicorns actually exist, but if there were to be, then this is how it would look. So take a look at the bottom of the page and you'll see, or the bottom of the screen, and you'll see two overlapping circles. The S circle represents the subject class, and the P circle represents the predicate class of a categorical claim, categorical proposition. And then the numbered areas are just those areas that we can diagram in specific ways in order to visually represent the logical structure of a claim. So in the case of all unicorns are mammals, we're going to diagram a part of the S circle as it relates to the distribution of S's into. Okay, with that in mind, let's look at how you can diagram each of these claims. So notice that in the upper left-hand corner, you have a universal affirmative, an A proposition. In the upper right-hand corner, you have a universal negative, or E proposition. In the lower left-hand corner, you have a particular affirmative, or I proposition. And in the lower right-hand corner, you have the O proposition, that is the particular negative. Now, first, let's talk about what we're seeing. And now that we've got our placement, the shading, the blue, represents emptiness. In other words, and that's not really the best language to use, but the shading tells us that there isn't anything here, there can't be anything here. So you want to think of the shading as saying, if there are any S's, they'd all be dumped into the P class. So look at area 2, that is the area of overlap of S and P. In the area of overlap is the only open place, or the only place available for any S's that may exist to actually be. So shading tells us that there's no there to put anything. There is nothing that we could put in the area of S that is outside of P. Now take a look at the E proposition immediately across from the A. Right? So the E proposition says no SRP. And that tells us that there is nothing you could put in the SP overlap area. That's because there can't be even one S that's a P or one P that's an S. Okay, let's go back to the universal affirmative. All S's are P's, but we have not assumed a member of the subject class. That means that there's no inference we can make from the universal to the particular, which is the I proposition in the lower left corner. But if you look at the lower left corner, you'll notice that there is a member of the subject class that is also a member of the predicate class. How do you know this? Because there's an X in the overlap area. The X in the overlap area says there is at least one S that is also a P. Now, cast your eyes to the lower right-hand corner. Notice there is an X in the area of S outside of P. That tells us that denotes that there is at least one S that is not a P. There is at least one S that the P class excludes from itself. So you've got these 3 areas. Yes, technically there are 4, but we're now talking about the relationship between S's and P's in terms of inclusion or exclusion of a member of the class, or in terms of the entirety of the class. So we're not looking outside of the S and the P classes in their entirety. Okay, so when you look at the O proposition, notice that, again, there is a member of the S class. Now cast your eyes diagonally to the universal affirmative. If it's true that there is a member of the S class that's outside of the P class, then that means that the universal affirmative can't be true, right? Remember, the universal affirmative says that there can't be anything in the area of S outside of P. So if the O proposition is true and there is a member of the S class outside of the P class, then the A proposition in the upper left corner must be false. You can see then also that the other direction is equally contradictory. If it's the case that the A proposition is true, then O proposition has to be false. These are known as contradictories. E and I are also contradictories. If the E proposition is true, then the I proposition must be false. If the I proposition is true, then the E must be false. I hope the diagrams help you see what the logical structure of each sentence is, and also how it is that the logical structure of the I proposition and E proposition are not simultaneously true, not simultaneously false. They're contradictories. Also, how the logical structure of the A and O propositions are contradictories. Here's how you can now see what we mean when we talk about a square of opposition. A's and O's are contradictories, E's and I's are contradictories. If the A is true, the O must be false. If the O is true, the A must be false. If the E is true, the I must be false. If the I is true, the E must be false. Any number of examples should any number of examples should suffice to help you see how, regardless of what the example is, right? So you can extrapolate from the examples. Regardless of what the example is, it's going to be the case that A's and O's and E's and I's are contradictories. Let's go ahead and look at some examples. So A's and O's are contradictories. All zoos are places where animals are treated humanely contradicts the claim some zoos are not places where animals are treated humanely. E's and I's are also contradictories. The claim no zoos are places where animals are treated humanely contradicts the claim some zoos are places where animals are treated humanely. Here are some more examples that I hope make clear what contradictories look like. All nurses are medical professionals. Some nurses are not medical professionals. Some medical professionals are not nurses. All medical professionals are nurses. Now, if we operate from the standpoint that we know the truth value of the first proposition in each pair, then I hope it's the case that we see clearly that the second proposition in each pair can't be true. So if it's true, and we believe that it is, that nurses are medical professionals, then it can't be true to say that one of them is not. Similarly, if we say that some medical professionals are not nurses, and it's fair to say that that's a true claim, then it must be false that all medical professionals are nurses. But just remember that these examples are meant to sort of pump your intuitions about contradictories, but the content is not what makes these contradictories. Instead, what makes these contradictories are their logical structures. So take a look at the second set, the E and the I, the second two sets, the E and the I propositions. Let's assume it's true that no nurses are people available for jury duty this week. It must be false, therefore, that there is even one nurse available for jury duty this week. Similarly, if it's true that there is at least one nurse that is a certified phlebotomist, then it must be false that none of them are. We're now going to move on to a discussion of other immediate inferences. So when you make an immediate inference, you are making an inference from one proposition to another. So we've seen that on the modern interpretation of the universal, there are two immediate inferences on the square of opposition, namely the contradictories A and O and the contradictories E and I. Now what we want to do is look at what sorts of inferences we can make when we internally manipulate a given proposition. And the result is conversion contraposition, and obversion. I do want to point out that it might be worth thinking about conversion and contraposition as mirroring each other. So conversion is going to be valid for two claim types, E and I, and contraposition is going to be valid for two claim types, A and O. The reason why I mention this is because most of us find that the contrapositive of a claim is very peculiar. It's not intuitive. And so if you think, okay, well, contraposition is just the symmetrical move for A and O propositions, and that move has a symmetry with conversion, or symmetry to conversion. So what do you do when you convert a claim? You switch the subject and predicate positions. What do you do when you contrapose a claim? First, or not necessarily first, but it makes more sense in some ways when you're writing things out, to switch the subject and predicate positions and then add the class complement to each. The class complement is articulated with the prefix non, and that tells us that we're talking about what is outside the class in question. And then obversion is valid for all four claim types, so you don't have to worry about restrictions, which you will see when we get to the traditional interpretation of the square of opposition and conversion, contraposition. So when you obvert a claim, you change the quality, and then you add the complement to the predicate class. Let's see how this looks when we're working on converting, contraposing, and obverting claims, and doing so with the Venn diagram might help you to see what is happening. Let's move on now to three more inference types that we can make. Remember that when we're talking about the square of opposition, we're talking about immediate inferences, and then conversion, obversion, and contraposition are three further immediate inferences. What I'd like to do is talk about conversion and contraposition as mirror inference types, and I think doing so might make it easier to grasp contraposition, which gets a little bit difficult because it's not a particularly intuitive inference type. So first, though, let's take a look at what conversion looks like from the standpoint of a Venn diagram. So we're looking at pairs, one on top of the other. So the far left inference goes from top to bottom. That's a universal. And then the second pair from the left is also a universal, then a particular, and another particular. So the first inference is universal affirmative to universal affirmative. The second inference is universal negative to universal negative. The third inference from the left is particular affirmative to particular affirmative. And then the last inference, the far right, is particular negative to particular negative. Let's go back to the first one on the left. Notice that the top and the bottom Venn diagrams don't match. That's because when you switch the subject and predicate places of the universal affirmative claim, you get a different diagram. If we say all S are P, and then we say all P are S, we do not have identical diagrams. That's because the logical structure doesn't match up. Think about it this way. If I say all nurses are medical professionals, and then I switch the subject and predicate places, I get all medical professionals are nurses. But clearly, it doesn't follow that just because all nurses are medical professionals, that all medical professionals are nurses. In other words, the subject class of the universal affirmative is distributed, but that does not mean that the distribution works both ways. Hence, when we convert a universal affirmative, we do not get an equivalent claim. Another way to say this is that converting a universal affirmative does not yield a true claim, or we could say that converting a universal affirmative is not a valid inference. Take a look, though, at the universal negative and the particular affirmative. No S or P is equivalent to no P or S. Why is that? Well, it's because the subject class is distributed and the predicate class is also distributed. In other words, we have mutual exclusivity. If none of the S's are P's, it also follows that none of the P's are S's. Even though nothing is distributed in the particular affirmative, when we say some S or P, we're saying that there is at least one S that is also a P. Or, and this might be more helpful, there is at least one thing that is both an S and a P, so that we can say there is at least one thing, therefore, that is both a P and an S. Lastly, take a look at how the particular negative inference is not equivalent. It's not a valid inference, because saying that some S are not P does not tell us that some P are not S. Let's go back to an example. To say that some nurses are not certified phlebotomists does not allow us to infer that some certified phlebotomists are not nurses. Here are some examples. Take a look at the first sentence in each pair and determine that the sentence is true based on your understanding. But even if you say that you're not sure whether or not the sentence is true, you can assume that it's true. Remember, the examples are meant to give you something sort of tangible to hold on to, but they're not meant to be that in virtue or by virtue of which an inference is valid. So pause and read through each of these and see if you grasp how it is that the conversion move is not valid for A and O propositions, but is valid for E and I propositions. And then when you're ready, let's move on. Here are the diagrams, the Venn diagrams for contraposition. Now remember I said that contraposition is going to feel to you perhaps a bit counterintuitive. So you start with the standard form claim A, E, I, and O, which you see on the top row. And then for each inference, you have on the bottom row the diagram for the result. So the first far left, and then the second from the left, the third from the left, and the far right, those are pairs on the vertical. So A to contraposed A, E to contraposed E, I to contraposed I, and O to contraposed O. Now, if you're having some trouble understanding the introduction of the class complement in terms of wrapping your head around something like the E proposition that is contraposed, no non-P or non-S, don't worry, you're not alone. I have a video that focuses on the class complement. You might want to look at that. But it's also, again, worth mentioning that contraposition is the mirror to conversion. So remember, conversion on the modern interpretation is valid for E and I. It's not valid for A and O. Contraposition on the modern interpretation is valid for A and O, not for E and I. So you can see where the mirroring or symmetry lies. Take a look at these diagrams, read through the premise and then the inference, and see if the diagrams help you make sense of things. Here are some examples. Again, I'm trying to pump your intuitions about claims you believe are true. But also, if you're not sure that the claim is true, you might want to go back to the Venn diagram to help you out. When you're ready, go ahead and move on, as we're going to finish the modern interpretation of immediate inferences discussion of obversion. Remember I mentioned in the slide that when discussing the slide that began the discussion of immediate inferences that are not on the square of opposition, I said that obversion is valid for all four claim types. Notice that the diagrams are identical from A to obverted claim, which is to its obverted claim, which is E to its obverted claim, which is A, I to its obverted claim, which is O, and O to its obverted claim, which is I. In addition, the obverted claim always adds the class complement to the predicate, and you'll see that the resulting diagrams are identical to the original. That tells you that since these statements, these propositions are logically equivalent, you can infer one from the other. Here are some examples. Take a look and see if you're comfortable with what it means to obvert a universal affirmative, a universal negative, particular affirmative, and particular negative. Here's a chart that may help you understand what is going on with the validity or invalidity of a given inference. So we've got conversion and contraposition on the two ends, and you'll notice that the A and the O are not valid for conversion. You can tell that by not only by what you already know, but by the X through the relevant boxes. And then the contrapositive is not valid for E and I. Again, you can tell that by the X's through the relevant boxes. Obversion, on the other hand, is valid for all four claim types. If you need a reminder of what to do when you take the converse, take the obverse, or take the contrapositive of a given claim, back up a few slides to where I offered you the procedure for each. I'll show it to you again right now if you don't want to back up through this video to the relevant slide, because I know that could be a little bit of a pain. So hold on just a sec. Okay, here are the steps. There's one step for conversion, 2 steps for contraposition, and 2 steps for obversion. We now move on to the square of opposition, as well as the immediate inferences, conversion, contraposition, and obversion, from the standpoint of the traditional interpretation of the universal claim. Remember that the traditional interpretation, or the Aristotelian interpretation of the universal claim, is that there is the assumption of existential import, which is to say, there's the assumption that a member of the subject class exists. You'll notice from the list here that this assumption makes possible quite a number of inferences. Things get a little bit complex, so you're going to probably want to think of how you might bear in mind what the inferences are that are valid on this interpretation, and then every other inference is undetermined or invalid. Okay, so what we're going to do is build first our traditional interpretation of the inferences we make around the square of opposition. And when I say build, what I mean is this. You can see already that we have in the 4 corners of the left pane, or the left side of your screen, the A, E, and I and O propositions. And what we're going to start with is the inferences that we can make from A to I and E to O. In other words, we're going to talk about subalternation, and we'll talk about why it is the case that under certain circumstances you can't infer the A from the I or the E from the O, and why under certain circumstances, and that will be the next slide, you can't infer the I from the A or the O from the E. But let's start with the A proposition, and the T in parentheses is the assumption that the A proposition is true. Now look at the blue arrow associated with that truth value, and it allows us, you can see, to infer a true I. So if an A proposition is true, the I proposition is true. Why is that the case? Well, take a look on the right side of your screen, and you'll see the first bullet point says all SRP, and then there's a further note. We assume there is a member of the S class. So if we're saying all SRP and there is an S, that means that it must be the case that some SRP. Now drop your eye to the third bullet point on the right side. What if we start with a true I proposition? Notice the two examples. When we start with a true I proposition, sometimes the universal, that is the superaltern, is false, and sometimes it's true. So when we say, it's true that some dogs are beagles, therefore all dogs are beagles, we've drawn an erroneous inference because the claim all dogs are beagles is false. And on the other hand, when we start with a different true I claim, some cats are animals, we can draw a true superaltern, that is a true universal affirmative, all cats are animals. So now draw your eye back over to the AI relationship. More specifically, look at the true I proposition, the second T in parentheses, and you'll see that the arrow going upwards leads to a question mark, which is to say that if the I proposition is true, the A proposition is undetermined. Why is the A proposition undetermined? Well, we just saw two examples where, when starting from an I proposition that's true, we sometimes get a true A and we sometimes get a false A. In other words, we're dependent on looking at the content in order to understand the inference. And since in logic, we want to avoid looking at the content to see if the inference is legitimate or not, we will say that we cannot infer the superaltern from the subaltern. Now, if you cast your eye over to the EO relationship, you'll see that it mirrors the AI, or another way to put it is the AI mirrors the EO. We can infer the subaltern from the universal proposition. The subaltern is the subaltern that corresponds to the universal. So a true E yields a true O, a true A yields a true I, but just as with the IA inference, the OE inference is undetermined. When the O is true, the E is undetermined, just like when the I is true, the A is undetermined. Go ahead and pause for a moment and read through the examples. You'll see that we have the same assumption for the E proposition as we do for the A. That is, we assume there is a member of the subject class. On this assumption, there must be at least one S member, which means that when the E is true, the O is true. When the A is true, the I is true. But it's not the case that when we start with a true I or a true O, we get a true, respectively, A or E. Now let's look at what happens when we have a false A or a false I, a false E, or a false O. Notice that when the A is false, the I is undetermined. When the E is false, the O is undetermined. Now take a look at the examples. So the first bullet point reads as follows. Suppose all SRP is false. On this assumption, the I proposition is undetermined. Look at the examples. All dogs are beagles, that's false. Some dogs are beagles, that's true. All rabbits are carnivores, that's false. Some rabbits are carnivores, that's false. When the inference is sometimes true, sometimes false, in other words, when the inference is not necessitated, it's undetermined. The same goes for the E to O proposition. That is, we cannot infer the subalternation for a false universal proposition. So suppose that no SRP is false. On this assumption, the O proposition is undetermined. The claim, no dogs are pit bulls, is false. The claim, some dogs are not pit bulls, is true. The claim, no cats are animals, is false. The claim, some cats are not animals, is also false, is also false. So you'll see in each of the immediate inferences here, the inference, respectively, some dogs are not pit bulls, some cats are not animals, are true and false. Now cast your eye back to the chart. More specifically, look at the I proposition under the assumption that it's false, and notice that the arrow leading upwards yields a false superaltern. The same goes with the O proposition. When the O is false, the E is false. Take a look at the examples for each before moving on. Now let's take a look at contradictories. Remember that contradictories are propositions that cannot be true at the same time, and they cannot be false at the same time. So we don't even need to know the truth value of the premise, because the immediate inference, the contradictory, will always have the opposite truth value. So we talked about contradictories in the following way. We said that any statement and its negation cannot be true at the same time. If I utter the sentence, I own an iPhone, and I also utter the sentence, I do not own an iPhone, we would say that I am being self-contradictory, or I am asserting self-contradictory statements if I try and claim that it's true that I own and I do not own an iPhone. You would basically say to me, look, Mia, pick one or the other, it can't be both. So, if an A claim is true, the O must be false, and vice versa. And if an E claim is true, the I must be false, and vice versa. Before moving on, go ahead and pause the video so that you can take a look at the examples. Now, I do want to point out, before we move on, that the examples that I give you are meant to pump your intuitions about the correctness or illegitimacy of certain inferences. But what we want to bear in mind, and what will be helpful to us as we move forward to understanding this notion, is that the logical structure, not the content, is what makes an inference legitimate or illegitimate. So when I say when we move on, I'm thinking of the Venn diagrams that will offer us a visual representation of the logical structure of each of these proposition types. Now let's move on to contraries. Universals are contraries. Take a look at the top blue bar. It's a bar rather than arrows because contraries do not have a reciprocal relationship with each other. Here's what I mean. Contraries can't both be true, but they can both be false. So in order for us to draw an inference from a universal to its contrary, we need to know that that universal is true. So take a look at the A proposition and the second arrow that goes from A to E, the second line, which is an arrow that goes from A to E. So the first arrow goes from A to E, And that is an arrow that tells us if the A proposition is true, the E must be false. Now look at the third line, or the second arrow. If the E proposition is true, the A must be false. If, like I said before, the E proposition or the A proposition is false, in other words, we start with a false universal, the contrary may be true, may be false, we just don't know. That's another way of saying what I had mentioned before when I said both universals can be false at the same time. That means then that when we start with a false universal, our inference is undetermined. Go ahead and take a look at each of the examples before we move on. The correlate to contraries is this pair of inferences known as subcontraries. So take your eyes down to your particular claims, I and O. You'll notice that on the very bottom, you have a bar that, like the bar in the A and E proposition references, is blank. In other words, there's no directional arrow. And that tells you that I and O and I inferences, that is, subcontraries, do not bear a reciprocal relationship to each other, just as contraries don't bear a reciprocal relationship to each other. You have to know the truth value of the premise, and even then, knowing the truth value of the premise might not or will not always give you the immediate inference or a necessary immediate inference. So, subcontraries can't both be false, but both can be true. So if an I proposition is false, so look at the top bar, the first arrow. If the I proposition is false, the O must be true. If the O proposition is false, the I must be true. The O to I inference is your second arrow and the second bar, if you will, in the series. So let's take a look at a couple of examples. We know that some iPhones are Androids is false. The subcontrary, some iPhones are not Androids, is true. Some guitars are not stringed instruments is false. Some guitars are stringed instruments is true. So you must know first that your particular proposition is false in order to draw the necessary inference that its subcontrary is true. On the other hand, it may be the case that your two particular claims, your subcontraries, are both true at the same time. So because if you start with a true particular, you may end up with a true or a false subcontrary, the inference from a true particular to its subcontrary is undetermined. Take a look at the examples. You'll notice that when you start with a true I, you sometimes get a true O, you sometimes get a false O. The same with starting with a true O. You sometimes get a true I, you sometimes get a false I. Because the inference is undetermined, we don't allow that inference as a necessary inference. What we've been looking at is the square of opposition from the traditional standpoint. And remember what that means. That means that we assume a member of the subject class in our two universal claims exists. So what we're going to want to do is distinguish between what's known as existential import, which is what reflects the traditional interpretation of the universal claim, from not assuming existential import, which is what reflects the modern interpretation of the universal claim. And when we understand the traditional Venn diagram, we understand in a new way or another way or a way that illuminates for us the inferences we are and are not allowed to make on the square of opposition. We'll also see why on the modern interpretation of the square of opposition, there is just one set of inferences allowed, contradictories, A and O, and E and I. Okay, so let me show you what you're looking at. If you take a look at the two circles, remember that we said when we're diagramming our propositions, rather than nesting circles or coming up with a different type of diagram for each proposition type, if we have two overlapping circles or two circles with an area of overlap, then that becomes our template for any of the four proposition types. These are called Venn diagrams. Now, the shading that you see, or in this specific case, the red lines, is going to represent emptiness. It's another way of saying that whatever S's there may be, they're all dumped into that area of overlap between the S and the P class. So on the traditional interpretation, when we say all S are P, we're saying that there's not even one S that is in the area of S outside of P. And by the way, the red circle, the red X that's circled tells us that in fact we assume there is an S. So think about it this way. When we say all dogs are animals, we assume there exists at least one member of the dog class. But now drop your eye down to the modern interpretation. The modern interpretation suspends judgment about existential import. And this helps us an awful lot when we think about propositions where we are pretty confident that the subject class is empty. All leprechauns are gold hoarders. All werewolves are frightening creatures. All vampires are blood-sucking undead. Those subject classes, leprechauns, werewolves, and vampires, don't have any members. So the modern interpretation says, look, whether we are talking about dogs, cats, tables, chairs, vampires, werewolves, leprechauns, fairies, whatever, we're not going to assume a member of the subject class. That is going to just complicate our inferences. In other words, the modern interpretation says that by not assuming existential import, we free ourselves completely from ever needing to know about the truth value of the proposition in question. Now let's take a look at the Venn diagrams for E propositions. The traditional interpretation, again, assumes a member of the subject class. And just as an aside, technically both the S and the P class assume membership. And we'll talk more about that in a little bit. But you can see that in both the traditional and the modern interpretation, the area of overlap is shaded. What that means is that the area of overlap between S and P is empty. There's nothing there. There can't be anything there. The traditional interpretation says no SRP, and by the way, we're assuming a member of the S class. The modern interpretation says no SRP, and we don't assume a member of the S class exists. Now, the Venn diagrams for I and O propositions are the same in both the modern and traditional interpretations because the modern and traditional interpretations are of the universal propositions alone. The interpretations do not impact at all the particular or existential claims, some S are P, some S are not P. Your I proposition has an X in the area of overlap, which denotes that there is an S and it's also a P. That's why it's in the area of overlap. The X outside the S class in the O proposition says there is an S and it is outside the P class. Another way you might consider this when you're thinking about the concept of distribution is that the P class rejects or precludes any S from participating in it or from being a part of it. So there is at least one S that is completely outside of P. Now let's look at the traditional square of opposition and our Venns. First, look at your two left side propositions. You've got your universal affirmative in the upper left corner and your particular affirmative in the bottom left corner. Notice that the A proposition includes the includes the I proposition. All SRP assumes a member of the S class. Hence, if all SRP is true, some SRP is also true. Notice that the same is the case with the E and the O propositions. Those are in your respectively upper right and lower right columns. Remember, A is in the upper left, I is in the lower left, E is in the upper right, O is in the lower right. No SRP includes a member of the subject class, which makes some S are not P true. Now let's take a look at your contradictories, because I think that the Venn diagrams are really going to help you understand how it is that contradictories look, or what it is, what the logical structure of the propositions are, such that if an A is true, the O must be false. So notice that in an A proposition, the S area outside of P is empty. Emptiness means there's nothing there. So if there's nothing there, you couldn't possibly have an X in the S area. Now take a look at the universal negative, the E claim. The E claim asserts that the area of overlap between S and P is empty. And if that's the case, there can't be an X in the area of overlap. Notice also that now look at the O claim again, if the O claim is true, if there is one member of the S class that's outside of P, that means there's a member of the S class in the area that is outside of the P class. If that's true, then the A claim diagonally to your upper left, can't be true. And the same also with your I and your E. So the diagrams help us understand how it is that contradictories work. Take a few minutes to think about, by way of your diagrams, how contraries, subcontraries, subalternation, and superalternation work or don't work based on our previous discussion of truth values. Now let's review obversion, conversion, and contraposition. Remember we said that the square of opposition on both the traditional and the modern interpretation is about making inferences between proposition types, between A and E, for example, or O and A. Obversion, conversion, and contraposition, on the other hand, are inferences that involve manipulating the proposition itself, not moving from one proposition to another. In other words, what we do with obversion, conversion, and contraposition is we take we take a specific claim type, not a particular claim. A particular claim is an O or an I claim. So to be more exacting, with obversion, conversion, and contraposition, we take a specific claim type and we manipulate its internal structure to see if the result is equivalent to the original. That's a really important point to remember. We're looking for equivalences. And I think you'll see these equivalences clearly by the Venn diagrams that we look at in a little bit. So first off, obversion. Obversion is the most robust immediate inference involving manipulation of a proposition's internal structure. It's the most robust because it's valid for all four claim types on both the traditional and modern interpretations. So here's what we do. We take a proposition and we change its quality. Remember, quantity is the how much, universal or particular. Quality is the mode or the in what way, which means affirmative or negative. So we leave the quantity alone, we change the quality, and we add the complement or a complement to the predicate. Now, the complement of a claim, remember, is everything outside of that class. And linguistically, that's designated with the expression non. So we get the following. The universal affirmative, all S or P, becomes no S or non-P. No S or P becomes all S or non-P. Some S or P becomes some S are not non-P. And some S or not P becomes some S are non-P. What you might consider doing is taking sentences that make sense to you. So, for example, all dogs are animals, right? And obverting each sentence so that you can have a more tangible understanding of how the logical structure of the obverted claim is equivalent to the original. Conversion is valid for E and I propositions on both interpretations. So it's got a restricted scope. In addition, conversion is valid by limitation for A propositions, but only on the traditional interpretation. In addition, conversion is never valid for O propositions. I think that you will more clearly recognize how conversion is or is not legitimate or is legitimate in a restricted way when you look at the converted claims, but also when you look at the Venn diagrams. So first off, conversion involves swapping or switching or changing the subject and predicate position. You'll see that for conversion by limitation, which works only on the A proposition, we first subalternate. In other words, we first move to the subaltern, which is an I claim, and then we convert the I claim. So let's look at our converted propositions. First, the A proposition becomes all P or S. If you think of a couple of examples that are tangible, you should recognize why this why this inference is not legitimate. If I say all dogs are animals, and then I infer from that all animals are dogs, we come up with a false proposition. On the other hand, if we say first that all dogs are animals, therefore some dogs are animals, therefore some animals are dogs, we're in good shape. That's conversion by limitation. Now let's look at the E proposition and its conversion. So no S or P becomes no P or S. If it's true that no rabbits are donkeys, it's also true that no donkeys are rabbits. Some S or P becomes some P or S. If it's true that some animals are dogs, it's also true that some dogs are animals. The O proposition, though, is never going to yield a valid conversion. Some S are not P is converted to some P are not S, but the inference is not valid. That's because some P are not S is not equivalent to some S are not P. If I say that some smartphones are not Androids, I am not saying the same things when I say some Androids are not smartphones. Lastly, let's look at contraposition. Contraposition does for A and O propositions what conversion does for E and I. Contraposition is valid for A and O propositions on both interpretations, valid by limitation for E propositions on the traditional interpretation only, just as, remember, conversion was valid on both interpretations for E and I, but valid by limitation on the traditional interpretation only for A. Similarly, contraposition is never valid for I propositions, and remember, conversion is never valid for O propositions. So we have mirror immediate inferences. There are two steps involved in contraposition for A and O propositions and for I propositions, and 3 steps for contraposition by limitation for E propositions. And actually, to be more exacting, I should say, there are 2 steps to contrapose A, E, I, and O propositions, and there are 3 steps to validly contrapose the E proposition. So what do? Well, we change the subject and predicate terms just like we do in conversion, but we have an additional step, which is to add the complement to each of the subject and predicate terms. So all S are P becomes all non-P are non-S. No S are P becomes no non-P are non-S. Some S are P becomes some non-P are non-S. And lastly, some S are not P becomes some non-P are not non-S. Now, if you're feeling a little bit dizzy because of all of the nons and the nos flying around, don't be surprised. It's normal. These are not super intuitive for us. I think, again, looking at tangible examples will help you. In addition, when we look at the Venn diagrams, I think you'll have a visual, I think having a visual representation of these logical structures will help you see their equivalences and why, when they're not equivalent, they're not equivalent. Before we move on, let's do what we did in conversion for the A proposition. Let's do that for the E proposition here in contraposition. When we say no S or P, if we drop down to some S are not P, and then we contrapose the claim, we've got a legitimate inference. We've got an equivalent inference, or an equivalent statement, an equivalent proposition. That's because, as we've seen already, contraposition for O propositions yields an equivalent proposition to the original. Remember, I noted that conversion and contraposition are mirror inferences. Conversion is valid on both interpretations for E and I. Contraposition is valid on both interpretations for A and O. Conversion is never valid for O propositions. Contraposition is never valid for I propositions. Conversion is valid by limitation on the traditional interpretation only for A propositions. Contraposition is valid by limitation only on the traditional interpretation for E propositions. Oh boy, that's a lot to think about. Let's look at this literally by way of Venn diagrams. So obversion, as you can see, is valid for all 4 claim types. Why is it valid for all 4 claim types? Well, notice that the obverted claim is visually the same as the original. Pause for a moment and look at each diagram. Notice that conversion on the traditional interpretation forces us to restrict the A proposition or to limit the A proposition to an I. So we first make the move from A to I, then we see that the conversion is equivalent to the original I proposition. But if we just convert the A proposition, we can see that the two diagrams are not equivalent. You'll see that the E and the I propositions are respectively equivalent to their originals. Notice that for the E proposition, I mentioned this earlier, but we assume existential import technically for both the subject and predicate classes because they're reciprocally distributed. Lastly, take a look at the O proposition. They don't match up, right? And there's no way to get them to match up. So the inference is not legitimate. So before we move on, think about this a little bit. Let me go back to obversion. When you have a diagram that's equivalent to the original, so here it is also for conversion, you have a valid inference. That's because these propositions logically say the same thing. Lastly, let's look at contraposition. We can see that the A proposition, when contraposed, is identical to the original. The same is also the case with the O proposition. But take a look at, respectively, E and I. They're hard to sort of wrap your head around in terms of saying no non-P or non-S or some non-P or non-S. And that's because these just aren't intuitive. But take a look at the diagrams and see if those help you to work through what the written statement asserts. Wow, we just covered a lot of ground. We covered sections D, E, F, and G. Now, you might want, when you review, to just cover D and E separately from F and G, but I do hope that this fairly detailed presentation of the modern and traditional interpretations of the universal claim and how those interpretations allow for inferences or not around the square of opposition, as well as the inferences called obversion, conversion, and contraposition, help you understand what categorical logic lets us do, and also how it helps us to, I hope, think more clearly about the language that we use. Next up, we will finish Chapter 5 with Section H, which is devoted to translating ordinary language into categorical propositions.